The machines took a big step forward today. We're talking about artificial intelligence and a Bay Area startup that's showing off what AI can do like we have never seen before.
But what does this mean for your jobs? And why were protesters outside the company's offices today? Let's bring in our business and tech reporter, Scott Budman, for some answers. Scott.
Well, Janelle and Terry, we are, of course, talking about OpenAI, which has a ton of funding from both Microsoft and Silicon Valley VCs. Today, they showed off what they've been using that money for, an update to a program called ChatGPT, where the AI now wants to be your friend.
Once upon a time, in a world not too different from ours.
And that's how the story of GPT-4 begins, with a phone that wants to be your friend, or at least help you with math.
The first step is to get all the terms with X on one side and the constants on the other side.
But even as OpenAI rolled out the latest chat product at its headquarters,
AI later, safety now! AI later, safety now!
A group called Pause AI protested outside.
We're out here asking for OpenAI to be reined in until we know that what they're doing is safe and that they're doing it in a safe way. And it really shouldn't be us doing that. It should be our government leaders.
Building multi-step applications and AI workflows shouldn't mean writing custom, complex code. Developers often spend too much time tracking progress, writing error handling logic, and managing retries instead of focusing on their innovation. AWS Lambda Durable Functions simplifies all of this. Write code using your programming language and IDE, while Durable Functions provides built-in patterns to manage progress and error handling. Build multi-step applications and AI workflows faster with Lambda Durable Functions without having to write complex logic or manage additional infrastructure. Get started today.
Biggest short-term risk for ungoverned AI?
I'm a huge enthusiast when it comes for AI. I believe that the level of productivity is extraordinary and the technology is moving very fast. You're going to see it used in every sector, in every company, and therefore you're not going to have really powerful companies and powerful individuals trying to stop it, which is what usually happens with the technological revolution. You get, post-carbon energy, and then all the coal and the oil people try to stop it, try to lobby against it. That's not happening in AI, so it's going to actually lead to a much bigger upside than people expect, much faster. But technology is moving much faster than the ability to govern it. And that means that the negative externalities, which one would expect from such a transformative technology, are going to happen very quickly, and they aren't going to be contained or constrained. What kind of negative externalities? Well, one obvious one is deep fakes and artificial intelligence used for disinformation. So, in an election like the United States, where so much is at stake, where people are so angry, where there's so much chaos that could come, we're moving from disinformation to AI-driven disinformation. That's a very significant disruptive risk. Then there's also the question of what bad actors can do to just blow things up. So you use AI to code, it's very impressive. Use AI to create malware, it's very dangerous and costly. Use AI to create vaccines. We love that. That actually got us out of COVID a lot faster than we otherwise would have been. Use AI to create new viruses and new diseases. We don't like that so much. And as you have these new incredible AI tools that are rolling out that everyone has access to, some of which are open source, and they will be used not just for productive purposes, but also by tinkerers and by bad actors, this is the first year we're going to start to see the negative impact of that more broadly.
Already starting to play an impact in our lives, particularly in public services like health and education. Now, the reason we're hosting this summit is because AI technology is developing at an incredible pace. The people who are developing the technology themselves have raised some concerns about what might happen, how it might be used by bad actors, and I want to take a lead in protecting the British people. That's why we...
Yo, 1 2 1 2 1 2 1 2 1 2.
All right.
Yo, what's up, Dak?
What's up, man?
What's up, man? Back at it again. I was saying to you backstage, this is episode number 13. Time went really fast, bro.
Oh yeah. Yes, indeed.
Man, you know, we were doing a study thing for like 3 months while I was in Peru, um, and it culminated perfectly. Headed to Vietnam, beginning of November. I took my exam middle of November, um, and then when you came back, and I had already taken the exam, it was just like, you know what? I think I got this. So I'm just gonna double down on my weaknesses and whatnot. I'll buy the 6-pack exam from Stefan Marek. That is a supplementary package to the course that Theo uses in the boot camp and whatnot. But not like in general, I think I got it. But this podcast actually ended up being a supplemental thing since we don't do the study sessions anymore. They're broad and sweeping conversations, but I think it's a good. I mean, at least from one, it's entertainment, it's content for the channel. It promotes, brothers being in tech, cloud in particular, leaning toward AI, machine learning, systems design, etc., and some engineering aspects. The brothers that want to go into that, but for me also, it is actually ended up. I was thinking the other day, ended up being kind of like a supplementary study session thing because it's like, while I'm actually learning this stuff and prepping up to take the exam again, I'm able to like infuse the conversations into like real world applications, scenarios. It's a it gives you a holistic perspective on the actual subject that you're studying. While when you're drilling and going through, reading the white papers and everything, and drilling on the practice exam questions and everything. I find it easier to learn when I can put it in context in the real world in terms of how a use case or something would be applied, and I think this is contributes well to that.
Oh yes, I mean being able to map it to something that you've either dealt with before or something that's been applied, an application, and you deal with it day to day with, it sticks. It tends to stick more in your mind, and it tends to be more relevant.
No, definitely. You were telling me before we got on that because I didn't know this, that you're actually writing kind of like in-depth articles based on your industry, and you're using that your LinkedIn as such, and that it's contributed to you networking with regard to career and everything
Yes. Yes.
on
So
LinkedIn.
yes, this is something that I extend to you and other people that are in the group. You have something that you learn, and you've done it, and it's something that you can explain. You can explain it in a way that is relevant to other people who cut the check, so to speak, cut the checks, who bring people onto the team, who sign the dotted line. Being able to teach what you've done, or to teach a particular technology and talk about how it works, why should your client care, business care, and where has it been a benefit? Where has it, drove efficiency? And you cite that. And it does help you indirectly because you bring people in who may have expertise in areas where you lack, and you can leverage and lean on them for other, future opportunities, or just to pick their brain when you're trying to pitch a particular solution or approach to a problem. So that's what it does. Long term, it helps strengthen the network, and for outreach.
Oh, you know what? I added Have you ever seen those study with me ASMRs or Pomodoros on YouTube? I actually watched them a lot last year. But and it's usually like kids and usually like engineering or mathematics majors or kids in law school or med school. But like there are whole channels where it's like the cameras are set up and it's like, study with me for 4 hours and it's like it's not even time lapse. Like you watch them sit up there and study and stuff like that. And then they'll do breaks with the Pomodoros and stuff. So I actually got really into actually that type of content. Normally, I'll usually like to watch the hot Asian chicks do it who are going to med school and shit. You know what I mean? 'Cause
Well,
it's like,
I know what you mean. When that kind of breaks it back when I was in university, I was studying with them.
yeah. So like, yeah, it'll usually be like a lot of Korean and Asian chicks for either med school or like some of them are at like Cambridge or Harvard. But so I study. I usually have 2 study sessions a day. Usually, like when I'm not. No, we streamed this morning, but I'm usually up early and I'll head to Starbucks or like one of the co-working spaces like early in the morning, like somewhere between 7 and 8, and I'll get my 2-3 hours in just going through notes, hand rewriting stuff, doubling down on stuff. The 2 domains I'm weakest in. Then I'll come back and start working on the channel, go to the gym or something like that, and then get ready for a stream that I would normally do in the evening. But because I'll be watching those Pomodoros and those study with me, I was like, you know what? I got this tech support joint. Sometimes, let me do one of these study with me joints, and I have it. I just started it this week. It's in the members section, so you wouldn't be able to see it. But here, look, I'm going to pull it up. I'll show you. Because I think I did one Monday. So hold on, let me pull it up. And I actually ended up liking doing it. Hold on. So this is the one I did 2 days ago. This was study with me. This is for the cert. So let me actually pull some of it up. And this was I think I studied for an hour and a half. And what I realized is, I can like turn this into like a study journal. Like your personal accountability partner type shit.
Right.
Like, did I actually study? Like, nah, well, it's live on air. I actually did study. So this was me. And what I did was I actually talked through some of it, like, because I use Obsidian, the Markdown tool, to like consolidate like my notes, PDFs, and stuff like that. Because you have notes all over the place, but Obsidian ends up being my main study repository. So I was showing them. You see, these are the slides from the Stephen Marek course. And then I showed how I used the LLM to consolidate the test questions that I got right and wrong. I turned them into a document, throw them into Google's pre-made LLM for you, the LLM notebook, and it generates all my study notes. And then I went through some of my study notes live. This is because, I'm weakest in cost optimization and the security domain. So that's, like our conversations that I've just doubled down. I have a theory. I'm just doubling down on security domain I took 2 of there's 6 tests in the new practice test package I bought. So I've taken 2 of them so far. And all I've done is consolidate the right and wrong answers and on both cost domains and security domains, and I've just been doubling down on them. So I'm going to retake both those tests next week, and I have a theory that because I didn't double down on the resilience or high performance stuff, so I'm going to see if I just doubling down on security and cost, if I retake the test again cold, if I get a percentage increase of my my score. You see what I mean?
Right. What you're doing essentially is you're looking at what a particular section where your weak point is. You're hammering down, like improving that area, and then going back and recycle through that exam prep, and that ought to increase your score. And you do that for the next domain, whichever one that is. Recycle through understanding what the concepts are, hammering that down, then recycle through the test again, get your points back up, and then of course your overall score is going to increase and put you in the passing section. So that's really what that's what I did, when I was studying for these exams, is that I would hammer down my weak points, go over them, then go and recycle through the process exam. Once I've achieved at least 80% or higher in that particular domain, I'm ready to go. Overall, everything else is good. I'm ready to go. Like set up a time to take my actual exam. So you should be on your way. And really, that's a common thing, though. Like the FinOps and the contingency, the disaster recovery, backup, those tend to be weak points in general in practice. So once you get this part here straight out, you should be good on the test, because a lot of the questions are driven towards, cost optimization and disaster recovery.
What you call it? So, and I was basically, I just figured it's turning out to be like one. You know how you just said earlier before, like if you could teach something, you know it. So this is like a cheat code for me. I get to study live. I get to make content in the members section, but it's not me just blindly studying. I actually talk through a bit and be like, okay, so people know what they're looking at. So this right here, these are because I'll remember I was saying to Josh, like, yo, you can use the LLM and it will create the study materials for you. So this is from the data set of just the correct and wrong questions from the cost domain, but these are some of the study materials the LLM generated for me. This slideshow and everything, and it's I absorbed the information better. So I was going through. This was me actively going through some of the study materials. This is my LLM. You see, I've got I uploaded the Kubernetes book. I uploaded 2 of the Kubernetes textbooks and stuff like that, because it makes mincemeat of huge onerous reading, and it gives you flashcards, mind maps, everything. So yeah, this is me going through the security domain section. And like I said, I'll double down, retake both of the practice exams, and see if my score increases significantly by just doubling down on those domains, because I tend to do really good at the high performance and systems resilience domain for some reason.
Right. Well, I mean, because that's what we started with first. Once you understand the system, you have to look at it from a macro perspective. Part of this, what drives the system, is the cost, the optimized cost of financials, whether it be the financials from a technical standpoint to the costs just from what the company can afford. What they can afford to implement.
All right, bet. So yeah, I wanted to show you that because it's in the members section, so you probably wouldn't have seen it. But yeah, and I did another one last night, and I was pressed for time yesterday because I had another live stream to go on at midnight, and I was like, you know what? Let me just put on the Pomodoro Live on air and just study for 30 minutes, and I actually got a lot done. So this is I think this has turned out to be a good study and content hack for me, ironically.
Yeah, I mean, putting in, you don't want to go too long. The sweet spot is like maybe 30 minutes to an hour a day. And because when you do it that way, you're focusing on the main points that you need to get through, and your retention is going to be a lot higher than going over that threshold. You're going 2-3 hours, and your mind's just going to be just fatigued. You're not going to be able to retain what you learned the day prior.
Well, you know what? That's a good point. I agree with that too. It's kind of I think maybe by default been my approach. Wait, can you hear me? Been my approach to
Yeah,
all right, cool, to a bunch of stuff. But like I said, these conversations weekly, for some reason, I think it's been helping me just understand the entire industry and the materials better in general because, like you said, I'm mapping it to something larger. It's not just, questions on an exam and information in a course and everything. When I look at it and I read and I'm listening to concepts, I can kind of map it to real world stuff now. Based off a lot of these conversations.
Right.
All right, so this is part of the podcast. Me and Theo went through just to begin the first round of questions on this the last podcast we did. So I actually want to just do a follow-up question on here because we're actually already at the 23-minute mark. It says this is from Amazon Web Services. This is from their official channel. But the conversation was with off-the-shelf AI won't cut it. The real deal on model customization. Amazon Web Services. The guy's the one who's actually doing the real designing and the heavy work. The female's more the one in the burgundy sweater is I guess she's more of a consultant or something like that. So a lot of her answers aren't going to be technical, but the guy's spot on with a bunch of stuff. So I'm actually going to jump into some of this. We're going to listen to some of this. I might have to fast forward through till she gets to a decent question, and then we'll take it from there.
Like sometimes we'll talk to organizations and they're like, I have a ton of data.
Right.
We're like, yes.
Good problem to have.
Yeah, we're like, yes, you have a large volume of data, but like, what is the data? And like, is it actually aligned to what you're trying to do? I think the other thing is the evaluations are so key, right? For most of the problems that we're working on in kind of the customization space, it's not like an off-the-shelf benchmark that we're trying to improve against. For a lot of like what we see, the foundation models have already been kind of like aligned to try and beat those leaderboard metrics, right? And so we're not going to like go and try and like do that, but it's more like we're trying to make the model follow the style and tone of your organization, right? And then you need to know, well, how do you measure that? And like, what does that look like? And how to, can we use another model as a judge of that? Or do we have to have human evaluations? Usually it's kind of a mixture. Sometimes it might be like more of a classification problem or like something that you could grade, right? Like a multi-choice quest, like a multi-choice test, you can figure out if the model answered the right answer. And so that's a big part. It's just figuring out what are you trying to achieve and how are you going to measure that? And then that sets you up a lot of the way because then anything you get as a baseline, that's now you can do a champion challenger and say, all right, can I improve the performance of that? Can I keep the performance but decrease latency? Like that gives you have to have that starting point to work from.
Sure. So it's like good compared to what, right?
Yeah,
and you need to establish that up front. So all this talk of data, Ali, is making me think a lot about, your clients in particular in highly regulated industries, knowing that, there's governance, there's security, there's compliance, there's, VPC considerations. So tell us about the conversations that you have when it comes to, you have a business leader that sees that flashiness aspect of AI and they want to get going. And then you're like, well, wait. There are some considerations here. So how does that go?
Yeah, so I had one of these conversations this morning, just before I came here. Coincidental, exactly. Yes. So it was with a very large defense company. As you can imagine, with us, the three broad categories that prevent an organization from rolling out a more like off-the-shelf solution as a sort of coding agent are some sort of government regulation, some sort of InfoSec, or IP worries. Right. Essentially, they don't want any of this to egress, or any of their information to egress their organization for one of those reasons.
Of course.
And when companies come and talk to us, because we are able to deploy into either a VPC or on occasion fully on-premise, there are a lot of questions that get raised. A lot of it around actually, is your solution truly truly air gapped and truly like deployed into just our infrastructure. Does it phone home in any way? But once we've got beyond that, then the conversations become centered around like, hey, we've seen all of these other tools that like we can't use. How analogous are you to them? Where do you match up on the evaluations, as Hannah mentioned? And also then comes often the killer question, which is like, hey, we have a use case in mind. The code base is like 25, 30 years old. It's mostly in the head of one guy who's retiring.
Naturally.
How can we use your tool to sort of like lift that load and actually make that a productive code base again? We get a lot of that sort of stuff. So yeah, I guess with these large organizations, they come to us in search for a solution that can actually be deployed in their highly regulated sort of environment. And once they've established that, then they're asking for all the bells and whistles.
Okay.
Yeah.
Let's stop it right there. And I'll do some quick decoding. Off-the-shelf AI solution, not always the most practical for some enterprise. In this case, defense client. We got IPsec concerns. We've got legacy code and infrastructure concerns. Is it going to be deployed on-prem or VPC, etc.? Those are some of the bullet points. What say you of the conversation in total?
I haven't listened to the entire thing yet, but one thing that sticks out to me that hasn't been spoken about is ownership. Taking ownership of the project, meaning, okay, he's a consultant. He's coming in there as, say, an AI consultant, data consultant, what have you. He is there as, okay, I'm here trying to get feedback on the people their processes and their technologies. So the application or the model is 25 to 30-year-old application. Okay, they understand that. Understand there are issues with security, given the fact that it is, defense related. So there's also issues with data sovereignty. Those are all valid. The reality of it is, someone has to take ownership, and the ownership lies within the consultant themselves, because I can go in and help someone and just with a logical architecture and then just walk away. But if I don't set up things in place to where it's a handoff, like I'm handing it off, but I'm handing it off with them a list of directives that they can put in that's going to develop into a rule book, documentation. Here are the stakeholders that we have from security. Maybe they're an ethicist, AI ethicist, whoever it is, the network, engineer, and architects. Bring them into the conversation, because they're trying to integrate this technology, right? Then they're talking about the data. Someone has to be assigned as the data owner on that project. Meaning, once it's handed off, this is the go-to person who's going to be handling with what we call the metadata management, the context behind the data, and making sure that they're auditing this process at the very beginning, which is kind of like what he hinted at. But someone has to enforce it, and that's as a AI architect, we have to take ownership of the project, and then start bringing people in, because this is a very meticulous integration. Because as he said, like the model, yes, there's canned models that are out there. But what if they have a model that they've been using for 25, 30 years? It's a local model. And then you have the issue of it, because it's proprietary, it's government, it's federal. They want to leverage on premises. So you have what's called an offline. So offline on premises is where all of the data cleanup is done, where it's like, okay, they have to essentially assess the management of the data, then going into how they're going to go about transforming that data. This is like before we even migrated to the cloud. So So that way, any data that's going to be brought into it does not contain any kind of information that's going to be like almost like PII, but also be anonymized to where it doesn't identify certain people or locations or anything that would be construed against the regulation compliance. Then you come in and you can talk about maybe we can integrate this into an AI cloud. Let's say we're using AWS for that matter. We can then migrate some of that transformed data into a medallion architecture, or just like there's a pre-raw staging data. Then from there, once they do that, that's going to include some compliance checks, some data security checks along the way. Then go to a civil layer, which may consist of that consumption of it into like some kind of ingestion layer where you can explain the data based on the context of the labels. And then there's, okay, now we have all that explained. Now we need to actually apply it, making that as part of an application, maybe a decision engine that they were referring to, a recommendation engine. It's a multi-tier process, but as you said before, if it's feasible to do it on premises, it's probably better in that case because they don't want to expose the data. So it's in a way they're wanting to virtualize. It's basically like virtualization. It's like virtualizing the data without exposing like all of the proprietary, all the secret stuff. So you can virtualize that on the cloud and use the cloud for the AI capabilities to actually do all that stuff. And it would just save a lot on costs. And then because you have the physical servers, they're able to have the adequate bandwidth that they need to do all the churning on the data and all that priming that goes into that.
All right, cool. Wait, wow, we're already at the 37-minute mark. I want to play a little bit more of this, see if there's something we can flesh off the bones. And if not, we're going to just jump to this is my architecture real quick, and we'll go through, we're going to do experience, scalable and flexible machine learning batch transformation.
Before you start, just want to make sure that like this, I'm just giving like this, I just gave like the added context and how kind of like there's other people in that conversation that go into doing the actual AI, like because it's like you're going into you can't just walk into someone's house and say, hey, look, no, you're a guest, so then they gotta you gotta follow, like you say, the rules of the game, and they want you to understand that, and you can work with them,
Yo, what up? Yearning and learning, listening while in the office. Good stuff. See,
all right.
I told you we're gonna gradually build up an audience for this. Because like I said, I think especially like in this particular space, we don't see, there's nothing with guys just talking real applicable, up-to-date tech, people who are actually gainfully employed in that industry and guys who are actively learning from all aspects of life, from blue collar to white collar. It's this is an anomaly, almost unicorn type podcast. You know what I mean?
Mm-hmm.
$6 million man.
Yeah, no, it's always tricky. I can imagine where it's like you want to be able to, whether it's for an agent, like replicate, a certain workflow, or in your case, like make use of the data, but it's not digitized, let alone on paper. I'm sure that's
yes. I mean, some of these code bases don't even use Git, which is something that we didn't anticipate up front. So you start getting hit with a lot of these kinds of questions, and over time our product will develop and become much more holistic in like, oh yeah, we have seen that once before, so we can deal with that. And every additional customer that we talk to, in this occasion this morning, they actually want a VPC deployment, which is great. So we can do those deployments much more quickly, and we can deliver them highly customized models, but like in their cloud. In this case, it was AWS, which is great.
Oh, good.
And in those situations, it means that also when they want custom models, which they often do on top of the custom agent that we already have, like that iteration cycle is much faster. We might be able to reach into their organization and use some of their data to train on their own code bases as well. We often get asked as that. Similar to Hannah, that's always sort of a last resort. We try to avoid doing that as much as we can, but in certain situations with
necessary.
Truly niche languages and use cases, you have to.
Okay. So Hannah, I want to go behind the scenes a little bit of the custom model program. When you see customers investing heavily in model customization, there are a lot of learnings, of course. But if there was to be kind of that one preventable failure that you've come across, we were like, we've just done that one thing a tiny bit differently, it might have been a different outcome.
Yeah. So I think a lot of the organizations we work with are already looking for insight and guidance. I would say one of the things is like, we already talked about working backward and having kind of the evaluation that you're going to use. That's like step number one. I think the other one too is like taking incremental steps. And so maybe by the end of this, you do need to make your own foundation model. But like, that's pretty rare. It's pretty rare that you have to like make your own new foundation model.
From scratch.
Yeah. But some people kind of think that they might need to start there. And so, I'm a big believer in only adding complexity when you need it, right? And so,
Smart.
Start with prompt engineering, start with RAG, and then, as you're moving into like, okay, we actually do need to modify the weights of a model, start with like parameter efficient fine tuning, right? Like a low rank adapter kind of fine tuning. You need less data for that, and the type of data that you need, you can probably use again if you do a deeper set of stuff.
Sure.
And so I would say, starting with something like a fine tuning, and even reinforcement learning before you jump into like, do we need to do continued pre-training or like more and more, right? The other nice thing about starting kind of at that higher level is it's also, a big part of what you want to develop is it's not going to be like a one and done thing, right? The space evolves so quickly. New models come out pretty frequently. And so one of the nice things is if you can get your pipeline, you get your data in place, you get your pipelines in place, you get your evaluations in place, really the model can be a pretty modular swap out at that point. And so think about ways to not over rely on the foundation model that you're using, but have all that other stuff around it so that you can kind of continue to iterate and experiment and kind of evolve with the landscape, right?
Interesting. And that's coming from the...
All right, hold on. Let's stop it right there. All right, I'm going to have to tell Theo next episode because we trashed her because...
you don't get me started. I won't necessarily trash her. This is a systemic problem. The systemic problem is that, and I've just talked about this in my recent LinkedIn article, is how there's always this pre-baked in bias on a particular framework that they read if you might have read in a white paper or something, and you're not looking at the problem face forward. Before we can even say, okay, we're going to apply reinforcement learning or some particular AI framework, we have to understand, one, the nature of the data, and then audit against the data to see if it actually is a fit for this particular application. One of the things that I've learned from one of my mentors is that we were talking about designing these systems. So you have what's called a small learning model, or a small language model. And that is something that's local for that company. So it takes all of their local data that they went in and labeled, and they've defined what the use case is, which is the first part, right? So you have the business case, you know what that is. Then it's the use case. The use case is so we have all this data that's already been labeled, you know what it is. It's in what they call a single source of truth. That single source of truth contains all of the data collected. So the small language model essentially is going to be your in-house chatbot. It's not reinventing the wheel. It's just taking the existing data that you have, and maybe you have local, because again, a lot of times they have proprietary, they may use econometrics data if it's for a financials company, or if it's for the healthcare, maybe like, someone is doing some type of biopsy research, and they have different types of informatics type of equations. You want to make sure, so those things are common, they're not rare. They're very common. What is also common is that there's a lot of misfires. About 95% of AI projects that go to fail to go to production. And one of the main reasons why is because people are coming in, leading with, hey, here's my solution, or here's my framework, here's the AI. And it's like, we don't even know what the problem is. We don't know the people in the room. We need to listen to them so that we can drive towards the framework before we even feel like there's the business case, then there's the use case. And then from that use case, we have what's called a logical architecture, or a logical framework. And a logical framework is technology agnostic. And then you go to like maybe a physical architecture and say, okay, we want this separated on-prem. We want to do all of our in-house offline work so that way we can get the data compliant to do modeling. And so one of the things that goes into that before we even talk about modeling the data on an AI that's in the cloud, an AI service, so that we want to inject what's called noise. It's essentially like when you're reading an instrument, let's say it's just, it has noise in it. And so it has a scalar, what they call a signal. It adjusts the signal to noise ratio. This is something that you have to inject in. And this is only for the AI itself. So that way it won't compromise on the integrity of the metrics. It's just something that you have to include when you're transferring that data from the on-premises transform data into the model, the AI model. But even before all of that, you have to decide what's the approach. Do we use machine learning, which is more predictive? There are models that you can use for that. But a lot of times they have stuff that's already baked in their company. So why would they want to lock in and buy a program that's black box? It can't even see what they're doing. But you're saying, okay, you take that faith that it's going to work. And that's why a lot of companies end up failing on these projects, because they don't go from the beginning, make security the priority and the data also priority, and bringing the other people in the room. This is not, I am someone who's, yes, I'm a data professional, but part of the overall structure is security networking in the business. And having those people in those conversations, it's what gets you towards a targeted solution that's going to work and that's going to be more stable. And that's something I noticed that was lacking in the video, but it's very common in the industry. I mean, you would be amazed at the fumbles. I'm talking about Fortune 500 companies fumbling millions because they were pimped out essentially by one of these providers or consultants, because they were just there to get the bag. They did not hand them off or take ownership of the data and put things in place so that when they leave, they can hand it off. They have security baked in, how they're going to do run like different drills, set up drills in place in case to do these worst case scenarios. So you bake in a culture of where it's like, yes, we're here to help you, but also we're also going to make it to where you're going to be what's the word? I'm here to make sure that you're reinforcing that it's the onus is on you, and that way you're going to be more involved in that, and you'll have less problems, with the project not going to production. It will more than likely go in production, being more stable. But you've got to go through it like stage to stage, audit it, because what ends up happening is someone's going to come in and the auditor is going to come in. Maybe it's the security auditor, and they're going to roll through the coals, on their checks on their data and other aspects of that. So it's better to start at the beginning to think about security than think about it as an afterthought.
No, I agree. I agree with that premise. Hold on for a second. If you can believe it or not, we're already at the 50-minute mark, bro.
Yeah.
That went fast.
Yes.
Yeah, that went fast. And we actually, we actually tried to speed through those questions. So, do you want me to pull up the architecture? I think
Yeah,
that's
let's go. Let's go for it.
that's a 5-minute segment. So this is Experian, and it's scalable and flexible machine learning batch. I already looked at the schematic. It's not. I mean, it's not as complicated as some of the other ones. So it's only a handful of components in this particular batch stack, but the services used and whatnot. And like I said, this is we seem to be taking it up a notch with the with the architectures every episode. I don't know if you know this or not. So we did you and I did Snap. That was the episode with you, myself, and Joshua.
Yeah.
And I did Snap again with Theo, the same AWS stack. So halfway through it, he's like, "Oh, thanks. This is going to be my. I'm gonna do a variation of this, and this is going to be the new Armageddon." And then he posted in the group, so everybody's pissed. Everybody in the group is pissed. Because Theo got the new Armageddon off of the schematic. So then, on Sunday, Theo's a bike rider. So I did the Peloton recommendation stack that they use, right? So then Theo goes in again and goes, this is a great idea for a project. I'm going to add this as an extra credit. So quiet storm, and people were in the chat like, "Yo, you're gonna have to stop doing these architecture reviews."
Oh man, it's so funny. You know what it's like? It's like that. I know it's a throwback, but it reminds me of the game Jenga.
Yeah.
You just keep stacking on the top, and you're just adding more. Eventually, it's kind of teeter-tottering. Whoever drops it loses. We'll see how far it goes, all right?
Yeah, the quiet storm was in the chat like, "Oh man," he's like, "You gonna have to discontinue this. This is my architecture segment." He was like, "Until then, complete ban on super chats."
Oh my goodness, that is so funny, man. That is so funny.
Oh shit. Yeah, and he posted. So this is the second time it's posted in both in the group. So. I'm going to go over this, and I think I might do the same model with Theo on Sunday. So cross your fingers you guys don't get a machine, because he's working with Bedrock now. You guys don't get an AI-inspired extra credit or another Armageddon based on this segment. Well, let's go, man. All right. And my volume up. Yes, it is. Let's go.
Hi, I'm Syed from Experian, and this is my architecture.
Well, let me take the banner off.
Thanks for being on the show, Syed. What do you guys do at Experian?
Experian is a data analytics and credit scoring company. So we get data from 400,000 plus institutions, financial institutions across the nation. We aggregate the data and provide consumers credit reports and the financial institutions to take decisions on their credit offerings like loans, auto loans, mortgages, etc.
Wonderful. So earlier we learned at Experian had simplified the machine learning model deployment for clients. So what are we going to talk about today? What business problem are you solving with the architecture that you also run on AWS?
Machine learning model onboarding is just a part of the MLOps platform, right? What comes after that is testing those machine learning models to work fine and training them to make it perfect and deploying them to production and running them in production for batch and real-time use case.
Great. So let's dive straight to it.
Absolutely.
All right. So let's go through the journey. Who's the user and how do they initiate a request?
So we have different sets of users. One of the main users is the data scientist who uses the portal to kick out these batch transform jobs.
Okay. With that request, do they have to submit any specific data or files?
When they do it through the portal, that information is just good enough to execute the entire campaign.
Wonderful.
Right.
And you send it to a managed Kafka?
Correct.
Correct? Okay. So walk us through kind of the back end. I see a lot of other AWS services. So what's the logic?
Yeah. So when the first message is written to the Kafka topic, so it is attached to this consumer. It is the orchestration consumer.
Okay.
They call it as the
Fargate.
orchestrator, which is on Fargate ECS. Correct. This guy determines the execution plan.
Okay.
Right.
So now you have the execution plan. But what's the set of events that is triggered?
Yes. So once the orchestrator determines the execution plan, it writes the message to another topic on MSK, which is managed streaming for Kafka, right?
I see.
Which is consumed by one or more consumers here.
And that sits on Fargate as well?
That is true.
And it listens on the topic you mentioned.
Yes.
Does that mean that you can have multiple of these happening at the same time?
Yes, exactly. So this whole architecture is event-driven, and these 4 units are, we call it as an operational functional unit, and they are independent, and they can be executed in parallel or as sequential.
So these are, what do you define as? Is it your processing engine?
Yes, it is the processing engine for the batch.
So let's go a little bit deeper here, right? So I see EMR, SageMaker. What are they used for?
Yes. Once the execution plan is determined by the orchestrator, and this consumer, which is the operational consumer, will know whether to execute a pre-processing job or any kind of job on a EMR cluster, or it has to trigger a batch transform job on a SageMaker.
I see. Give us some examples. Like, why would you use EMR for pre-processing?
So when a job is triggered, right, it could be relying on more than one data source, and these data sources could be in different formats. So we use an EMR cluster to get the data from different sources, make it available in a different format so that it can be easily consumed by the SageMaker.
I see. So it's transforming the data pretty much for you into SageMaker, what you do. Okay, model. And then in SageMaker, you provide an endpoint. This is the deployment or testing of the model?
Yeah,
is that
so
correct?
this architecture is used for testing, training, as well as production batch models.
And production.
Yes.
Wonderful. And any given point in time, as a user, say in this case, a data scientist, I want to get an update as to where this is.
Oh, yeah.
How do you facilitate that?
Yeah. So when this consumer triggers the jobs, right? So it also writes the message to Kafka topic so that the next sequential action can be triggered. Right. And not just that, it also writes the message to the open source service, which is our metadata store.
So you can then see kind of the status.
Exactly.
Okay.
So there are APIs which pulls the data from the open source store and relays the current state of job for the users.
What's the function of an event bridge?
Good question. So the entire architecture is event driven, like I said. So when there are jobs, state changes happening on the EMR cluster or the SageMaker, they are written or they are actually emitted to event bridge. We consume that, right? So this consumes a message, and based on the rules, it writes to, actually it is consumed by another Fargate consumer, which writes the messages to the Kafka topic, which determines the next sequence of actions.
Oh, so you can run many different ensembles pretty much, right? Of these. Okay, wonderful. And I also see another Fargate here.
Oh, yeah. So this is the last consumer, which is actually the notifier. So this consumer or consumers can do sequential steps, right? But this consumer is the action consumer or the notifier consumer, which consumes the messages all along and determines if it is the end of the execution of a batch campaign. And when this consumer determines that it is the end of the execution, so it writes a message to the portal through different mechanisms, or it writes a message to the open source service. So it lets the
notifies the user.
Exactly.
Wonderful. And you're probably running this at scale. So tell us a little bit more. Like, at what scale is this?
Yeah, we easily run about like hundreds of batch campaigns, thousands of models and jobs, and billions of consumers, actually tens of billions of consumers every month. And it is easily scalable. That's the whole point of this whole architecture.
That's really impressive. I'll say thanks so much for sharing this story.
Thank you, and absolutely a pleasure.
All right, cool. Let me run back to the schematic with all the final arrows drawn. Hold on. Yeah, here we go. And bang. All right.
I would have drew this a bit differently because the way it's drawn, it's unnecessarily complicated. One, all right, so he says he has the data scientist. Kafka, let's just start with Kafka first place. Okay, so essentially Kafka is a managed streaming. So he doesn't explain when you switch to real time and like going from batch to real time. Two, like there is like, okay, I see that he's using his ForGate as an orchestration layer. He has 3 ForGates. He doesn't designate within the design which, like, it doesn't explicitly say which ForGate does, because they're different aspects of it. So let's say the first ForGate that's at the top, that's supposed to be where they receive the messages, the queue, right? So Kafka does queuing, and it's also can also do like streaming. That it could work as a way to as a pipeline, right? So you receive the data, and it's lots of data. You have multiple clients. So the ForGate cluster, that process that it does when it retrieves the request to ingest the data, and using an EMR cluster. So again, like, where is that data pulled from? It should show, like, okay, is this on premises? How are they doing this? This is kind of like, this is a bad design in my opinion. I mean, I understand, that 5 minutes on there, but to me, it should at least be clearly designed in a stepwise format. 1, 2, 3, label what that process is. It just has ForGate for each of those 3. It's not very clear, at least in the explanation to me. I mean, I understand what he's saying, but if you're someone that's trying to like learn this, you're kind of lost. What say you? What say you?
No. I agree. I mean, but I did. The what you said? Yes. It looks like there's 3 ForGate. The 3 ForGate layers. Is that's what the
3
light
processes that are happening, like 3 large orchestrations
simultaneously or in parallel. So
right.
As indicated by the light blue dotted lines. Whatchamacallit? I agree with you. Like, I think they give you like simplified versions of the actual architecture, so it's a bite-sized conversation.
I would say that the previous people who've been on there, some of them done a better job in, like, okay, when they do the flow diagram, like you're seeing the arrow going from one process to the next. And if it's going back to that particular user, let's say it's a data scientist, they can do an API call. So they'll have, like, say, for example, there was one that we did before where they just call it the API layer. They didn't, they abstracted that. It was an abstraction layer. Like, adding that into it, it's not something that's too complicated to add in the design. It just makes it a lot more legible is what I'm talking about. Like the legibility.
Yeah, I agree. I would have liked for them to explain what's in the different ForGate containers.
Yeah, it's just, to me, like, I understand what they're trying to do is that, so if someone wants to get their credit score approved, they got to go through, they have to compute all that through a certain system. They do certain models, and so then they go through multiple models, and they see if there is a trend where based upon all of these information that they got from the client, and they'll either approve or disapprove their loan, or rate your score based on whatever those metrics are, whether it be FICO or if it's some other proprietary credit score metric. And I get all of that. Like, I understand, like, within that, that it scales, because it scales based on customer demand, client demand, and then there's the event-driven behavior, going between, processing that data that's going into the SageMaker models, that's going to, execute and give, those metrics based upon that model's analysis, and then circle back to that other Fargate at the bottom, which then feeds the result, it gives a notification back to the user. It's just spaghetti. You might look at it. It's just like spaghetti. If they would just label, like, just say, okay, instead of having Fargate there, just say, okay, this is like step one, and you know, instead of having just AWS Fargate. That to me is just a poor design. But that's not really main criticism of it. But I mean, other than that, I mean, I thought he did, you know, a good job explaining what the use case was for. It's just the design is too. It definitely needs some retooling. But otherwise, it was a good video.
No, I'm with you on that. Actually, I think you inadvertently pointed something out with regard to that. That's where that whole it's like when we were learning advanced calculus, like sophomore year at university, and the professor comes in and he fills up half a board with like stuff from the middle of the book, but you're really on like the second chapter of the freaking calculus book. But he's writing the stuff that's in the middle, and everyone's in class like, what is going on? And that ends up being like, oh, the magic of mathematics. It's the same thing with this, like drawing out explanations and drawing out a lot of these dots.
You know what the other thing too?
It ends up being like it ends up making it extra. It ends up adding to that whole the magic and mystique of IT.
Right.
AWS magic.
Yeah. And you know what too? One of my mentor, he says, there's a difference between being a good architect and a great architect. What makes a great architect is someone that can go beyond talking about the technology and actually make it relevant to the end user without like in real time. Meaning you can take this architecture that you have here, but instead of using Fargate or EventBridge, you can use the business terms that apply to that to that client. And then it just sticks more because you're mapping it to something that they're a process that they're trying to improve. You know,
yeah, well, you've got to be
like
you've got to be able to take that. I think
it's the speech.
I think that's what 10x to my performance. When I took the SAA the first time, it was because you simplify our study says you simplified a lot of complex system design concepts and some rules of thumb and how to think through use cases. So when I actually took the exam, I wasn't relying on my memory. I was relying on my memory in terms of knowing what the services were and how they function. But in terms of solving the use case, it was more so a matter of being able to put them together and identify integration and identify answers that just logically didn't make any sense because of my fundamental understanding of some of the core AWS web services. Does that make sense?
Absolutely. And then when a lot of times before you even do implementation, remember I told you there's a logical architecture before you get to the physical architecture. And one of those things is that it's like the art of reading the room. Like you're working with people who are not technical as well as people that are technical. You're that bridge. And so when you're having somebody that's the system engineer that designs it, they have to have in mind the audience that it's just like someone that's a graphic designer. They're not, if they just did the art for themselves, then they're probably going to lose that client's probably not going to go back to them again. You're having to take into consideration what their inputs are from the human side, and also weave that into the design so that you have a design that not only addresses the framework or the solution, it also maps to the human use case, the human problem that you're trying to resolve. That aspect of it really makes sense because you're not just implementing the technology, you're a solution or an architecture, you're interweaving something that's going to, that's going to help ease on the people that are going to be in that system. It's going to make it to where you take into consideration the human psychology that goes behind this. You want something that, is it going to frustrate people? Yeah, it may work, but it's going to work. But you may have people like throwing like a brick at their computer because it's not fluid, with the human machine relationship, so to speak, human technology relationship.
No, I think that's 100% spot on. And if you could believe it or not, that is time. 1 hour, 11 minutes. I gotta get you up out of here, bro.
Yeah.
Whatchamacallit? So another episode down. This was another good one, bro. Like I said, I think the level of difficulty is gradually increasing as we get comfortable with the conversation.
I would say that one thing I find that's difficult, it goes back to the end of the day, is the speed jobs. It's the communications. Not so much the technology, but like make things make sense. That's a process that you have to go by asking, it's like the scientific method. I have an hypothesis, I perform some tests, there's a conclusion. But in between there, it's understanding why am I doing this and what do they want, and so being able to map it and take those complex, dynamics into a palatable form that people could understand before we go into implementing with certain technologies. Because the technology, we know that's going to be there, but it's like I said, AI is always changing, updating technology. As an architect, I can give references on, I can keep up the date on what's coming, but I don't really have the time. But I can give that information, I hand it off to engineers who can play around and test out these technologies and implement it. That's my role as an architect, is to bring back learning, to upskill and improve the people who are on that project, and putting them in the hands to where, yes, I trust them enough to go and run through the implementations because they're good at it. That's what they do. Like, I can't do it all,
Yeah, 100%. Hello, can you hear me?
Yeah, this is great, man. This is a great session, man. Great session.
Yeah, we got another one for the books. It's episode 13. I guess listen to the replay. I've developed the ability to listen in third person for doing this for so long. Like, I can be engaged, but it's oddly listen as a third person. Like, how does this sound overall to the audience? So yeah, this was a pretty good one. Yeah, any final words? And I'll let you go, man. And I guess we'll tap back in next week.
Yeah. I just want to say this was, again, thank you for bringing me on. This is another great session. I think this one's I thought was really great because it tackles more on the psychology behind the thought process. Like, okay, how should we effectively, think as whether you're a developer, engineer, someone that does compliance work. How do we think through problems? Or do we just go in and allow projects that we've done before to govern what we do in the future? I mean, they're there, but if we're not careful, it can lock us down. It can stop us from thinking creatively to solve the problem that's in our face, like face forward. So I think this particular episode, what we were was to me, I thought it was a really good exercise of that, observing those type of things, as well as, of course, seeing the solutions, how is it applied to different sectors, or in the case for it being the military, defense, and then also financials, dealing with credit.
No, spot on. What we double down on Kelsey a lot because he's a good avatar for the mission statement and theme of this podcast, as it were. But I had started the initial conversation with Theo on Sunday because he was pretty excited because he'd been working out labs and stuff with Bedrock and everything. So that just took on a life of its own. I ended up pulling up this this system design conversation with some of the seniors over at AWS in terms of these off-the-shelf models, and we had only got through the first section of a question. So, I knew you were coming on Thursday, and I said, let's just continue that conversation. So this has been between Sunday and this has been a nice parallel or continuance of a conversation, which culminated very well, I might say. That being said, man, I'll let you. Oh, no, go ahead.
Yeah, this was excellent, man. This is the kind of conversations that help bake in the intuition that makes you be more limber when you're tackling, especially for the guys who are going through Armageddon. This will help get them at least a little more perspective on how they should be thinking.
Yeah, 100%. I'm actually really, like I said, I like this podcast. I think if we get to 50 episodes, this is going to be a nice archive of basically the progression with Theo University and then all of the alumni and all the guys who are getting hired and everything. It's going to be a nice little piece of, I think, a sleeper piece of history. I don't know. I'm usually pretty right about this type of thing.
Yes. Yeah, man, absolutely. Well, thank you again. And to all you all who are watching or are watching the replay, thank you all for watching. And hopefully I know whatever little bit you've got out of it, I mean, it's going to go a long way. So don't just keep it up. And this is great, man. Thanks a lot for having me on, and we'll sign off from here.
Yes, sir. See you next week. To everybody, man, we will see you next week, and I might see you tonight if I do a random stream.